Hi everyone, Kyle Boyar, Vice Chair of the American Chemical Society's Cannabis Chemistry Subdivision here. And today we're at Nature Safe Labs, a testing laboratory in Southern California. And today we're gonna be walking through how this goes from the farm to the shelf for the consumer. So why do we even do cannabis testing anyway? What's the importance of it? Well, if you were taking Tylenol, wouldn't you want to know the dose of the Tylenol that you were taking? How many pills do you take? 1, 2, 3? Without the dosage, it's kind of hard to know what you should be taking in order to get the optimal result. Similarly, if you were consuming any type of natural product, you want to make sure that it is free of contaminants. Like, is there mold on it? I probably don't want to be smoking that if there's mold on it. Are there pesticides? Well, I probably don't want to ingest that or smoke that either. These things are really important, especially when you're dealing with populations that are immunocompromised, and that's why we do cannabis testing. CANN exists to provide a foundation of professionalism and scientific integrity and inclusion within the cannabis industry. Our goal is to build the cannabis chemistry community by connecting people with others in the field and build their networks. First thing we're going to do is log in the sample and undergo a sessioning. All of the pertinent information about the sample is captured within the sample field log and chain of custody forms. And then we select which analyses are going to be performed on this particular sample. In this case, we're going to be covering California compliance testing, which includes So after sample intake, we're going to want to photograph the sample. How does the consumer even know what they're buying if they can't even see it? So first things first is we want to make sure that the consumer can see what they're buying and give it that nice bag appeal. After we photograph the sample, we're going to be looking a little more closely at it for filth and foreign materials. These filth and foreign materials could be anything from hair, rat feces, bug droppings, you name it, anything from the manufacturing process that could be left behind. We're going to want to look into that a little more closely and make sure that there's nothing visible on the sample. So here we are at the homogenization room, and the importance of homogenization is whenever you're doing any type of analysis, you want to make sure you're getting a representative sample. You can't just take the prettiest bud and say that this is representative of a 10-pound batch, because let's be real, that's not the case. So what we're going to do is we're going to take our entire sample and place it in this NutriBullet. Here we are in the microbial room, and we're going to be performing microbial analysis with qPCR. So the first step here is going to be we're going to take a 1 gram sample of our flower as per BCC requirements. This is arguably one of the most important analyses for cannabis. There are lots of different microbes that live within cannabis, and some of them are pathogenic. In the case of immunocompromised individuals, this could be very detrimental and could result in lung infections or worse, death if the wrong person consumes a contaminated product. So for inhaled products, the BCC requires that 4 different species of Aspergillus are tested for, as well as Salmonella and Shika toxin-producing E. coli. The 4 species of Aspergillus that we're dealing with are all pathogenic. That's Aspergillus flamus, fumigatus, niger, and terreus. So once our sample is in the tryptic soy broth, it's going to be important to place it in the incubator for what we call enrichment. Enrichment is going to be important because if you consider contamination in a cannabis sample, sometimes there's a very small amount of microbial contaminant in there. So if you're searching for a needle in a haystack, why wouldn't you let those cells grow and multiply so that when you subsample, you can actually hit the target if it's present? So I'm going to go ahead and place this in the incubator. We're going to incubate that for 24 hours at 37°C, and then we can actually perform our DNA extraction. So when we're testing cannabis from microbial contaminants via qPCR, the first thing we're going to want to do is extract DNA from that cannabis sample. That is the cannabis DNA and the microbial DNA that is present. So the first thing we're going to do is we are going to take out that 1 ml subsample. We're going to go off the side that does not have the sample on it to make sure that we don't get any debris. As many cannabis scientists know, cannabis is a notoriously difficult matrix to analyze. The reason for this is you have upwards of 30% expression of cannabinoids, terpenes, and other compounds. So a key point here is we want to clean up our sample to make sure that we can get exactly what we need from it without having all the background noise. As I said, in cannabis analysis, one of the most important things to do is make sure that our matrix is under control and we're able to get what we need out of our sample. So what I'm going to do here is I'm going to spin down this sample. So I'm going to go ahead and add this into our centrifuge, making sure that we're counterbalanced on the other side. And we're going to close it up. Now let's spin it. The trichomes and all of the other material is going to pellet down at the bottom, and that's going to enable us to get as clean of a matrix as possible. So as you can see now, we have a lot clearer of a solution. All of our trichomes, all of our excess plant material has been pelleted to the bottom of this microcentrifuge tube, and now we can actually perform the DNA extraction. So here we are in the microbial room at NatureSafe Labs, and this is a qPCR instrument. For those of you who don't know what PCR is, PCR stands for polymerase chain reaction, and then the Q just stands for quantitative. So in quantitative polymerase chain reaction, what we're doing is we're amplifying certain sequences of DNA associated with different pathogens that could be found in cannabis. Basically what happens here is during a regular PCR, we just have this amplification occurring with no fluorescent marker to be able to tell. But with quantitative PCR, we're utilizing different fluorophores to be able to visualize the amplification process as it occurs in real time. So here we are at the water activity station, and water activity is important for cannabis products because it measures how much water is available for microbes to grow. If that water content is below a certain level, then we know that there is not going to be any further microbial growth. So the first thing I'm going to do here is take some of my sample, fill this cuvette. Now we're going to open up our hygrometer, place the cuvette into the slot, and we're going to get a reading of the AW value. While we don't do this in California, another type of test for microbial contaminants that's worth mentioning are total count tests. So this can either be done with that qPCR or via plating methods typically. And what total count tests do is they don't necessarily count for things that are potentially pathogenic or harmful, but they do give kind of a broad overview of the microbial communities found within cannabis. And if there's high counts of these total count tests, then it could be indicative that there could be something more nefarious lurking in your cannabis sample. Now that we've done the microbial portion of the analysis, now we're going to move into potency. So the first thing I'm going to do here is I'm going to take a small sample of our flower and place it in this 50 ml conical tube. So now I'm going to dilute our sample in some methanol here. And the reason why I'm going to dilute this in methanol is because alcohols readily dissolve cannabinoids and terpenes. The next thing we're going to do here is we're going to vortex the sample. So now that our cannabinoids are in solution, what's going to be important is to dilute this down to the appropriate concentration such that it's going to be on our calibration curve so that the instrument can properly quantify it. So first, I'm going to take a little bit of the sample and add it to our 2 ml volumetric flask. And next, I'm going to take some methanol and dilute this down. So what's going to be important here is that we dilute it down so that it has a nice meniscus. So that surface tension is going to create a nice little lip just above the line. And then we're going to go ahead and close this up, invert a couple times just to make sure that we're nicely mixed. And now we're ready to analyze the sample. So now we're going to take our volumetric flask and dump it into this 2 ml amber vial. We'll close that up. And now the sample is ready to be loaded onto the instrument for potency analysis. So this here is an HPLC equipped with a photodiode array detector, and this is what we're going to use to do the potency analysis. So basically what will happen is that amber vial that we prepared earlier, a small sample of the liquid within it is going to be collected by the syringe in here, and it's going to get injected onto a column. And that column is going to be separating out all the different components within the sample. At the end of that column is a detector, the photodiode array. And in this case, it's shooting a wavelength of UV light, and the cannabinoids are going to absorb that particular wavelength of UV light. And this is going to cause different peaks, which is what we call our chromatogram. Basically, what you can do is you can take the area under that curve and then use that, based on your calibration points, to quantify the amount of cannabinoids within that sample. For residual solvent analysis, we're going to take a little bit of our extract, or an oil in this case, and we're going to place it within this headspace vial. Next, we're going to go ahead and take one of these tops here, and we're going to use this electronic crimper. That's going to seal our vial shut so it's gas tight, and now we're ready to throw it in the instrument for analysis. So one part of the analysis that we didn't talk about is residual solvent analysis, and we didn't talk about it before because we were testing a flower, but this is going to be important for any type of extract sample in particular. So what happens here is we get our extract sample and place it within a headspace vial. And what this does is it's a vessel that contains our gases that escape from the actual sample when we heat it up in this oven. And what happens is we're going to take a small sample of the gas and then run it through the gas chromatograph. What the gas chromatograph does is it's going to separate out all the different components again, and then we always have a detector at the end, right? So this is a headspace gas chromatograph coupled with a single quad mass spectrometer. From there, we can actually quantify what types of residual solvents are within our sample. So now we're moving on to pesticide analysis. And in California, we're required to test for 66 different pesticides, and this is typically done using two different instruments, an LC triple quad and a GC triple quad. However, in this laboratory, we're equipped with an instrument that is capable of using two different sources, both an ESI and an APCI. This enables us to capture all of the different pesticides required for California analysis in one instrument. So first, I'm going to weigh the sample. All right. So now I'm going to go ahead and add my acetonitrile to the sample. So now we're going to do the same thing as last time, and we are going to vortex our sample to ensure that everything was within solution. Here we are at the pesticide station, which is equipped with an LC triple quad. So it's the same idea as what we did over at the potency station to a degree. So firstly, we're going to take a little bit of our sample. It's going to get injected on a column just like before, except now at the end of that column is a different type of detector. In this case, it's a mass spectrometer. And so what happens here is you have a source, and it has two different ionization sources. It's got ESI and APCI. And using those different ionization sources, we're going to ionize our molecules, and then we're going to have them run through and get fragmented by the different quadrupoles within here. And basically what we can see here is the different fragmentation patterns, which will confirm or deny the presence of a particular pesticide. So next we're going to be moving towards heavy metal analysis. The reason why heavy metal analysis is important in cannabis is because cannabis is a bioaccumulator of numerous heavy metals. So if there is any type of heavy metal contamination in the soil, this can easily be uptaken by the roots and end up in your final product. So we want to make sure that we don't have any arsenic, cadmium, lead, or mercury within the sample. So we're going to go ahead and take our sample, and we are going to place it within our digestion vessel here. So now we're going to move over to the hood because we're going to be working with some acids in order to digest our sample. First thing we're going to do is we're going to add our gold spiking solution. What that gold spiking solution does is it prevents the metal ions from being stuck onto other things, and it's going to keep those metal ions within solution. Next, we're going to add our nitric acid in order to digest the sample. Next, we're going to be working with a bit more concentrated nitric acid. Now that we've waited for 30 minutes, we're going to go ahead and add our hydrogen peroxide. So now that we've added all of our solutions, now I'm going to go ahead and cap the digestion vessel. And we'll go ahead and move over to our microwave digester here. We'll place the digestion vessel into the microwave digester. So now we're going to seal this up and tighten it. Close up the microwave digester, and we're ready to get digesting. Here we are in the heavy metals analysis room, and this is an inductively coupled plasma mass spectrometer, or ICP-MS. And what this does is it utilizes a plasma source in order to ionize our metal samples, and basically we're going to be quantifying the big four heavy metals. That's arsenic, cadmium, lead, and mercury. These things have various action levels depending on what type of route of administration. So if you're eating it, it might be a bit higher than, say, if you're inhaling it. But ultimately, it's an important safety test for cannabis and cannabis products. Although we covered residual solvents, we did not cover terpene analysis. And while it's not required in California to do terpene analysis, it is a really important analysis nonetheless, because it does dictate a lot of the different effects that you get from cannabis in a phenomenon known as the entourage effect. There are a couple different ways you can test for terpenes. One of them would be using these headspace vials, like we talked about before for residual solvents. And this is going to have it so that the terpenes volatilize into this, and then we take a small sample of it and inject it onto our column. Now, the other way we could do this is in a 2 ml amber vial, so using a liquid sample. The problem with that is, instead of having a very clean matrix as you would in the headspace vial, now you have a lot of other junk in there that is going to cause a lot of instrument maintenance to be required over time. So either way works, just depends on how clean you want the matrix. So now that you've seen a little bit about cannabis analysis, you might want to know, well, how do I get into the industry? First thing starts with education. You can get degrees in chemistry, microbiology, neuroscience, biochemistry. Neuroscience is my major personally. And all of those things would be ample for setting you up for this type of career. If you can't get a career in a cannabis testing lab right away, you could always work at another type of lab, something like an environmental lab or a toxicology lab, because these utilize many of the same instruments that are used in the cannabis testing lab, and will give you a little bit of insight as far as how to do analysis prior to dealing with everyone's favorite matrix, cannabis.